Here is where we are. You have built something genuinely real. An assistant that reads your own notes, answers with sources, calls tools to get things done, and remembers you between sessions. On your own machine for free. So you open it up, type a question, and wait. The cursor just sits there. Then finally the whole answer appears at once several seconds later. It works, but it does not feel ready. And if you were paying a cloud provider per use instead of running it locally, every one of those slow calls would also be quietly adding to a bill. This is the moment almost every project stalls. The demo works, but it is too slow or too expensive to actually live with. The gap between a thing that works once and a thing people use every day. Today we close that gap. And here is the good news. You do not rewrite anything. You add a few standard moves and the toy becomes a tool. First, let us be honest about how real this gap is, because it is not just you. Across the industry, a huge share of AI projects work beautifully as a demo and then never make it into something people actually use. One widely cited forecast estimated that around a third of generative AI projects would be abandoned right after the proof of concept stage, for reasons like cost creeping up, or the thing just not being dependable enough day to day. Hold that number loosely, the exact figure moves around, but the shape of it is rock solid. The hard part of building with AI was never getting a clever demo to run once. It is everything between that demo and a product. And almost all of that everything comes down to three feelings a user has. Is it fast? Is it cheap enough to keep running? And can I actually open it and use it? So we will take those one at a time. Start with speed, because the first fix barely touches the model at all. It changes how the answer is delivered. Right now, your app waits for the model to finish the entire response and only then shows it. So the user stares at nothing for the whole generation, then gets a wall of text. But think about how the model actually writes. One word at a time in order, just like in Season 1. The first word is ready almost immediately. The trick, and it is the single highest impact thing you can do, is to stop hoarding those words. Send each one to the screen the instant it is produced. This is called streaming. And here is the part to be precise about, because it is easy to overclaim. Streaming does not make the model finish any faster. The total time to the last word is exactly the same. What changes is when the first word appears. There is even a name for that moment. Time to first token. With streaming, that drops from seconds to almost instant. And that is what people actually feel. A blank screen for 4 seconds feels broken. The same 4 seconds with words flowing the whole time feels alive. You did not speed up the model. You changed waiting into watching. Let us see it for real on your own machine. Same local model as always, QN3 running free through Alama. First, the way most prototypes start. I ask a question and my code waits for the entire answer before printing anything. Watch the screen, nothing, still nothing. And then the whole paragraph all at once. Now I change one thing. I tell the same call to stream, same model, same question, and watch. The words start almost immediately and just keep coming like someone typing live. Look at the 2 clocks. The total time to finish is basically identical. But the time to the first word went from a few seconds down to a fraction of 1. Nothing about the model changed. I just stopped making the user wait for the end before showing the beginning. Speed handled. Now cost and repeated waiting. Look closely at the calls your assistant makes and you will notice it does a lot of the exact same work over and over. Every single time it answers, it rereads the same long system prompt, the same instructions, maybe the same big chunk of your notes you pasted in for context. That repeated text is not free. If you are hosted, you pay to process it every time. And even locally, the model spends real effort chewing through it again before it ever gets to your new question. The fix has a name: prompt caching. The idea is simple. The first time the model processes that long, unchanging beginning, you save the result. On the next call, instead of redoing all that work, it just reuses what was already processed and jumps straight to the new part. The major providers do this for you, some automatically once the reused part is long enough. And the savings are real, though the exact figures shift, so hold them loosely. On the repeated chunk, costs can drop by something like half, and on some providers up to roughly 90%, while the time to that first word can fall sharply too. One rule makes it work. Keep the unchanging stuff at the very start and put the part that changes, your actual question, at the end. Same prefix every time so there is something to reuse. Prompt caching reuses the same beginning, but there is a bigger kind of repetition. Different users asking basically the same thing. When does my Netflix renew? When is my Netflix subscription up? How long until Netflix charges me again? 3 different sentences, 1 identical answer. Calling the full model 3 separate times for that is pure waste. So here is the clever move. Semantic caching. Watch how it differs from a plain cache. A plain cache only matches text that is exactly the same character for character. Change one word and it misses. A semantic cache matches by meaning. It uses the embeddings from Season 1, the map where similar meanings sit close together to recognize that all 3 of those questions are really the same question. So the first time it asks the model and stores the answer. The next time a close enough question comes in, it just hands back the stored answer, instantly, with no model call at all. Free. Now the honest catch, because this one has teeth. Close enough is a judgment call that you set. Set the bar too loose, and the cache confidently returns the answer to a question that only looked similar. A subtly wrong reply delivered fast. So you tune how similar is similar enough and you accept that trade-off. Used carefully on the repetitive questions, it can take a real bite out of cost and latency. Used carelessly, it lies to people quickly. One more cost move and it is almost too obvious once you see it. Not every question your assistant gets is hard. Some are trivial. What day is it? Reformat this list. Say that more simply. And some are genuinely hard, needing real reasoning over your documents. Right now, you probably send all of them to the same model, your one big, capable, slower model, which means you are paying your most expensive engine to answer questions a tiny one could nail. The move is called model routing. You put a quick, cheap step in front that takes one look at the incoming question and decides. Easy. Send it to a small, fast model. Hard. Send it up to the big one. Most questions in practice are easy. So most of the time, you run the cheap, fast path and you save the heavy model for when it actually earns its cost. How much does this save? It depends entirely on your mix of questions, so treat any single number with suspicion. But to give you a sense of the ceiling, one well-known research router reported keeping most of a top model's quality while sending only a small fraction of questions to it. The honest catch. That little router in front has to guess how hard a question is, and sometimes it guesses wrong. It sends a hard question to the small model and gets a worse answer. So you keep the routing simple and you watch where it misfires. Fast, cheaper. There is one feeling left, and it is the one that quietly kills the most projects. Can I actually use this? Right now, your assistant probably lives as a script you run in a terminal. That is perfect for you, the builder. It is useless for anyone else and honestly a little annoying even for you. Turning a script into something usable does not mean spinning up servers in some data center. At builder altitude, it is 2 small, standard pieces. 1. Wrap your assistant in a tiny web service. A small API, just a few lines with a free tool like Fast API, so that other programs or a web page can send it a question and get an answer back over a normal web request. And here is a gift you already have. Llama, the thing running your model, already exposes exactly this kind of local interface, so your local model behaves just like a hosted one your code can call. 2. Put a minimal face on it. A simple chat window using a free tool like Streamlit or Gradio, or a ready-made local interface like OpenWebUI, so a person types in a box and reads the reply, no terminal in sight. That is the whole leap from script to product at this level. A small door in for code and a small window for people. Still free. Still entirely on your own machine. Let us make 2 of these real the way you actually would. We already saw streaming flip a frozen screen into a live one. Now the cache. I will ask my local assistant a question it has never seen. When does my Netflix renew? It thinks, calls the model, works it out, and answers. Takes a moment. Now I add a tiny cache in my own code, just a small store that remembers questions and their answers, and I ask the exact same thing again. Watch the clock. The answer comes back instantly, and notice the model was never even called. Zero work, zero cost on a repeat. That is the whole principle in a few lines, running free and local. No new model, no cloud, just standard plumbing wrapped around the assistant you already built, turning something that merely worked into something genuinely nice to use. So step back and look at what just happened. The gap between a demo and a product felt huge, and we closed it without rewriting a single thing. Streaming so it feels fast, caching the same prefix and the same meanings reused so it costs less and waits less, routing so easy questions take the cheap path, and a small API with a simple face so a real person can actually open it. 4 standard moves, all free, all local. Now the honest limit, because there always is one. Underneath these moves sits a whole deeper world. How a serving engine juggles many users at once, how it reuses computation across them, the real machinery that makes AI fast and cheap at massive scale. That is genuinely fascinating and genuinely deep, and it is a story for a later season, not something you need to ship. What you have now is the builder's toolkit, and it is enough. Which brings us, finally, to the end of the road we have been walking all season. You have built every piece. Answering from your notes, tools, reliability, memory, and now fast, cheap, and usable. Next time we put it all together. One assistant assembled, running offline, that knows your documents, does things, and that you can actually trust. The second brain we promised you in episode 1. That is the capstone, and it is where we finish.